In this video, we're going to take a look at example 10.5.3, where we approximate the area of a region underneath sort of an unusual curve using the trapezoidal approximation method. So here's our curve. It's given by f at x equals sine x over x. And our boundaries are from x equals pi over 4 to x equals 3 pi over 4. Now, if you calculate pi over 4 as a decimal, you will actually end up getting 0.785. So here's our pi over 4, and then 3 pi over 4 is going to be your 2.356. So if we take a look at this, there's actually 1, 2, 3, 4, 5, 6 columns in between those. And since we're using 3 trapezoids, that's actually pretty easy to divide it into 3 trapezoids of equal, well, height, I guess, right? Because remember, this is actually the height of the trapezoid. And again, remember that the area of a trapezoid is equal to half times the height times the sum of the two bases. Okay, so now let me finish off this trapezoid for you, because you'll see how good of an approximation it's going to be. I'll use even a thinner line here. So from that point to that point, I mean, look at that. That's almost right on the curve. And then from this point to this point is your second trapezoid. A little bit off there. Let's try that again. So there's your second trapezoid, and then your third trapezoid goes from here to there. So really, it's pretty easy if we just simply go and apply the formula. So we've got area is equal to half times the height. Now the height is, see, that's what we have to figure out there. So if you take pi over 4 and 3 pi over 4, and you take their difference, then I think you can see that it's 2 pi over 4, right? So the height, I'll just do a quick calculation here. The height is actually 3 pi over 4 minus 2 pi over 4. Minus 1 pi over 4, I should say, which gives you 2 pi over 4. And then that, we want to divide that into 3 equal triangles. So another way of saying that is to multiply by a third. And believe it or not, that gives you actually pi over 6. Okay, so if we add a pi over 6 plus another pi over 6 plus another pi over 6, in fact, 3 pi over 6 reduces to pi over 2, doesn't it? So essentially, when all is said and done, we're just going to keep adding pi over 6, right? That's going to be our height. So let me just write that down. So it's pi over 6. Right? So the first pi over 6, if we add pi over 6, that's going to take us to, I believe it's 5 pi over 12. And then if we add another pi over 6, in some ways this reminds me of standard deviations, okay, 7 pi over 12. And then if we add another another pi over 6, we end up with 3 pi over 4. Okay, so that's it. We are on our way. I guess I should stick with red. So base 1 would be the value of the function evaluated right at the leftmost point, because this is your base 1, which would be f at pi over 4. And then base 2 in this case would be f at, on the right hand side of the trapezoid, f at 5 pi over 12. Now, here's the thing. From doing a trapezoidal approximation previously, I know that I'm going to have to add, when I go to the second trapezoid, I'm going to have to add 5 pi over 12 again. So I might as well just call this 2 f at 5 pi over 12. And then I can continue with the right-hand side of this trapezoid. So that'll be plus f at 7 pi over 12. Did you notice that little subtlety there where I left a bit of space there between the plus and the f? Because I know that I'm going to have to count this side again. So plus f at 7 pi over 12. Then when I go into the final trapezoid, again, I have to count this side. So there's actually going to be 2. So that was my subtlety there. Unfortunately, my subtlety didn't allow me to continue to write on this line, but that's okay. Plus the final side of the last trapezoid, which is f at 3 pi over 4. Okay, there it is. Okay, and then when we put all this together, we're going to end up with half times pi over 6, which is pi over 12. And I guess with this part, I don't want to belabor it, but f at pi over 4 would basically be substituting pi over 4 into this function. So sine pi over 4 is root 2 over 2 divided by, again, pi over 4. Anyways, I put all this in the calculator and I ended up with something like this, 0.9 plus 2 times 0.74 plus 2 times 0.53 approximately. And do I have room for one more? Plus 0.3. Okay, so and then at the end of the day, this is going to end up basically being pi over 12 is really 0.26, I think it was. And then all of this together turned out to be about 2.5. So I'll just write approximately equal to, and then the final result was approximately equal to 0.656 or something like that. I'll round it to 0.66. Okay, and that's the end of the video using the trapezoidal approximation to approximate the area underneath this curve. And we know it should be pretty close, right? Because look at these shapes. There's hardly any overages. They're just very slim.